Aloha Pomaikai friends, it's Mrs. Rankin. We're getting ready to create our pH indicator and use this indicator to test some substances around our house to see if they are acid or base. So I'm going to explain to you right now what's happening inside our cup or our jar when we test the different solutions and how it works with the pH indicator. Now, if you're my younger friends in kindergarten, first or second grade, this explanation might be a little complicated. So perhaps your parent or someone in your family, an older brother or sister or a cousin, could watch this with you and then maybe draw some pictures to explain it. But for some of my older friends, third, fourth, fifth grade, I think you can follow along and understand some of the basics of the chemistry that's involved. So when we have a solution, that's a chemical that's dissolved in water. So I'm just going to make myself a big cup on my paper here. Just going to kind of make a cup shape. And I'm just going to draw like a water line. So if we put into this jar some water, right? We might know that water is symbolized as H2O. And what that means is that water is a molecule, so a combination of atoms that's one oxygen and two hydrogen. That's why we say H2O. So it might look something like this. Sometimes I think of it as like a little Mickey Mouse ears with the oxygen and the two hydrogens. And it is a little bit off-centered like that. A water molecule isn't completely balanced, okay? And for reasons that you'll learn a little bit later on in your chemistry life, the different atoms in the molecule have different charges, kind of like on a battery where you see a plus on one side and a negative on the other. So this water molecule has charges. Some parts of it have a negative charge and some parts of it have a positive charge. And you know, that really helps hold it together in what's called a hydrogen bond that holds it together. But it also makes some interesting things happen when water comes in contact with other solutions that also have charge. So for example, let's take a solution, maybe something that we're going to use in our testing. And maybe it's a molecule made up of two different atoms that are represented by the blue and the black. When we go ahead and add that to our container of water, a curious thing is going to happen. The charges on the water molecule are going to pull this apart so that this molecule is going to separate into individual atoms and join together with the charged parts of the water. So it's going to become separate and no longer have the same structure as it would have had. So if it's something that dissolves completely in water like salt or sugar, you might see something like this. Now I will say when you get older, you're going to learn that there's a little different process in this solution making here, in this dissolving, between molecules that are joined together in different ways. There's something called ionic bonds and something called covalent bonds. So that's way later, like maybe high school chemistry. But if you can remember this model, you'll have an easier time understanding how it is when we add some of our different household solutions or chemicals into our pH indicator. Why are we going to get different results? Well, it's because depending on what's in the solution that we add, there may be a different number of hydrogen ions in this container of water plus chemical. And that's what the indicator is going to react to. And that's the H in pH. So that's our potential hydrogen. We're measuring the amount of hydrogen ions. And that's why we call it pH. All right, we're going to go ahead and set this paper aside. Now that we understand a little bit more about that process, I'll go ahead and pop that down on the floor next to me. And I want to prepare for what we might see in our test by making a color chart that we can use to show the different hydrogen ion amounts or the pH levels in our solutions. So I just got a white piece of paper and I have my colored pencils here. You could use some markers, or you could use some crayons. If you have crayons or colored pencils, it might be best because we can overlap and shade colors to get different values, and I think that might be really helpful for us. So I've made a line here to show the pH, and so I'm going to label the top of this pH scale with cabbage indicator. Oh, I hope I can fit it. Okay. pH scale with cabbage indicator. Let me turn that toward you so you can see that. And that's because this is our scale for the pH values, and our indicator is a cabbage indicator. Now, you can see it's like a number line with one end and another. I'm going to label my low end with the number 1. And then I'm going to label the top end with the number 14. Let me move that so you can see that. Oops, move it the other way, Mrs. Rankin. From 1 to 14. Now, I could be very precise and use my ruler here, but I think I'm just going to go and find what looks like the middle. So maybe that's like, Shaka's not going to do it. It's the length of my forearm, maybe right about the middle there. What number would be in the middle of 1 and 14? So 7. Yeah, so I'm going to label the middle 7. I make a little cross on my 7s. Maybe you don't do that. And then I'm going to find the midpoint of these too. So if I take 7 and I subtract 1, I get 6. And then what's half? So this distance is 6. What's half of 6? If I had 6 things and I divided them into 2 equal piles, how many things would be in each pile? So if you're not sure, you can take 6 of something, 1, 2, 3, 4, 5, 6 pencils, and divide them into 2 equal piles. How many pencils are in each pile? 3, okay? So then I'm going to add 3 pencils back. 3 plus 1 is 4. So I'm going to find this midpoint, and I'm going to label it 4. Same thing here. So this is a little different because I didn't start at 0. So I'm going to find that midpoint there, which is going to be a half of a number. So I'm just going to go ahead and add 3 onto there, and that put my 10 right about here. And now I'm going to fill it in. I need a 1, a 2, a 3, a 4, then 4 to 7. So I need a 5 and a 6, 5 and 6. 7 to 10, I need an 8 and a 9. And 10 to 14, I need an 11, a 12, and a 13. Okay, so there's my pH scale going from 1 to 14. My numbers down here that have a very low pH value, these are my acids. The high pH values, the high numbers here, these are bases, or we say basic. You might hear people say alkaline. That's another word for basic. And in the middle here, these things are neutral. They're neither acid nor basic. They're neutral. And now I'm going to add some colors. All right. When I use my pH indicator, things that come out as acids might be some reds, some bright pinks and reds, and maybe slightly lighter pink. So I'm just going to make myself some swatches, just looking at what I have here for my with my colored pencils. So these might be some of the colors that I expect to see with the pH indicator. I'm going to go ahead and color them in. So kind of a bright pink. It's not a gentle pink. It's pretty bright. Yeah, so it wouldn't be, for example, like this kind of pink, like little piggy pink I think of. And then I have a bright red. And maybe this little bit darker pink. Okay, so these might be some of the colors I expect to see in my indicator. if the solution is an acid. Okay, now I'm going to go to my neutral value, and that's going to be kind of the color of my indicator, which perhaps you can see here is it's like a bluish purple. Okay, so those are going to be neutral. And then how about basic or alkaline? Those are going to be maybe some bright blue, an intense blue, I'm pushing pretty hard on my pencils here to get a dark color. Okay, and then sometimes it comes out a little bit more of a teal, a little blue-green. You can see we're sort of moving away from the violet color, adding a little more green. So let's get a value in here that looks pretty green. Might be a little brighter. And can you see that I'm getting a little more yellow in the screen? If we find a very basic or alkaline, we might wind up with something that is almost a yellow. So I think I'm going to mix here. I'm going to take this bright green that I just had, and I'm going to layer over it with my yellow. That's one good thing about using colored pencils, yeah? You can kind of get that shaded effect. You can see that difference. All right, I feel pretty good about this. So now we have a scale. We have our reds and pinks down here on the acid scale, the low pH values. Neutral is a sort of a blue-violet. And then the basics are a bright blue ranging through the greens, and maybe we might even see almost a yellowish color. And this is the colors we might expect to see with our cabbage indicator. Now we're going to go to our test, and then we'll use these values and see if we can make sense of our results.